Good. So I'm Peter. Blaine and Simon are here. They will be following me. But we're here to talk about our journey into Bazel world. We started with our Maven conversion for a small set of assets inside of Salesforce about a year ago. It's a part-time job for us, so we don't work on it all the time. But we're going to be talking about We're going to be talking about a number of things. But the biggest thing we had to deal with was how to coexist with Maven, and so that's going to be the main focus of our talk. Another company, Redfin, did a great presentation about this same topic a little while ago, and that's also out there. And they took a different approach, and they had different requirements, and so they had to do things differently than us. But that's a really good. If this topic applies to you, be sure to catch that as well. And so let's get started. Oh, that one. So Salesforce is, I would consider, a big company now. We have about 30,000 employees. Not all of us are developers, so we don't beat Google. Google has 30,000 developers. We have a lot of salespeople and such, but we have thousands of developers. We have, of course, hundreds of development teams, hundreds, if not thousands, of products that go out there. Across the company, we use a number of different programming languages, different architectures. Some are monolith-based architectures. Some products are built with microservices-based architectures. But the team that we're on is really focused on accelerating the development of Java-based microservices. And so our talk and really the focus of our migration was really focused on that, although some of the things that we do get consumed by some monolith products. And so it's not entirely set on just microservices, but that is our focus. And so when we started our Bazel journey, we had, as a team, we were supporting a number of libraries written in Java, a number of microservices written in Java, and but they were all in isolated Git repositories. For our libraries, Maven would build them and ship them up to Nexus, which is our Maven repository. And then for services, we just had hand-rolled scripts that would create Docker images and ship those. And Melody covered a lot of these topics this morning in the keynote, but we had issues with just continuous integration. So if somebody updates a library, and then we find out 6 months later that broke a service, et cetera. We had dependency hell. We had just basic questions that we would do, get repository searches looking for users of particular libraries to find out who's actually using the thing. And as Melody said, emergency security patches were an issue. Also, when we upgraded a JDK across the company, it was kind of hard to go and test all the impacts to that. So we started on the monorepo solution to this about a year ago. We've been working on it off and on. We started with Bazel 0.5. And so the goals were to have all these libraries and services in the same repositories. You make one change, and you see the impacts right away. And as Dimitri was saying, one of the goals of Bazel now is to do, kind of support the gradual rollout use case, which is really important to us because for Salesforce, we cannot switch out Bazel or switch out Maven overnight and drop in a new build system. This has to be a coexistence strategy. So Simon's going to talk a little bit about how we support Maven projects consuming artifacts out of our Bazel repository. And then of course we want to have a positive experience for our end users. So we had a number of challenges. I'm going to cover the first couple, and then these guys will take over. So the first thing we had a year ago out of the gate, we used something called Spring Boot, which is it's a Java container system for building runtimes in Java. And so we started out of the gate with not having support for that. And then so Spring Boot requires a custom executable jar format. And so a year ago, I opened up Bazel and saw that there was a Java binary rule written in Java. And so I took that and forked it and wrote my own for Spring Boot, and that was a bad solution because we ended up having a fork of Bazel. So I then had to port it to Skylark, now Starlark. So that's been it was a pretty good experience. The documentation back a year ago was not as good as it is today. But in general, that's worked well for us. So if you have Spring Boot apps, we do have an open source solution for this that's out. You can find it on our Git account. And then another thing we have is at Salesforce, we have a centralized team for doing all CI. And so that's been an interesting dance with them to get support for Bazel. And so what we had to do, so we have Jenkins with Kubernetes deployed for build nodes. And so we had to roll a custom Docker image that we send into the system, and then that runs our entire build. Today, right now, what happens is when it starts up, it runs the entire build for the entire repository, but our build times are getting way too slow. And so we're coming here to find out some better solutions to do that. One thing we want to do is have team scope jobs. Once again, right now, when someone makes any change anywhere in the monorepo, our CI system builds the world, which is not ideal. I think, Blaine, you're next.
Okay. So the next thing we had to do is we have Docker support. So we have a lot of like Docker files because we're trying to do microservices. But they're like a free-for-all. So a lot of the early issues we had with the Docker rules and Bazel is because of the Docker rules assume they want it to be simple. You can't do run commands. You can't change like ownership of files inside the Docker file. We had a lot of things like that. And just recently we went through and we picked a service and went all Docker rules on it. And what we wind up doing is our security forces us to run with certain users, with certain permissions when they start up the Docker image. So what we had to do is we created like a parent Docker rule and then a Docker file that we do manually, but it's up there, it's cached, and then we pull that one down for all the Docker rules that we're using inside of Bazel. And so far, that's working out pretty good. I think right now we're at 2 or 3 services. We just got that finished. So, like I said before, the Docker rules were all free for all. So we're just trying to get those kind of like to be simpler because the Docker rule expects things to be a lot simpler. So. And for other custom tooling we've had to do is we came up with the flaky test framework. Right now, everything in Bazel, if you use the flaky tag, it runs everything at a class level, and we needed things at a method level to tag. So what we did is a very simple algorithm is we run our test normally, and from the BEP output, we find out which ones are wrong, find which methods, and then once we do that, we do an add ignore, which basically takes a flapping or flaky test and just ignores it for the entire build, which is not ideal because at some point we're going to want to run those flaky and flapping tests put them back into our build, but once they're more deterministic. So basically, this was done to stop people from when they would make a branch, they'd go to do the pull request, and all of a sudden they've got all these tests failing, but it's nowhere inside their code because right now it's a part of our continuous integration and it runs everything. And so right now we can actually just do a simple grep. You can find out which are the flaky tests, and then the developer who's owning it can then go fix it and put it back into the build. And if it fails again, we mark it again as flaky. So the things we'd like to do in the future is we would, like to have a custom annotation since we need to go down to the method level. And that way we could actually, as part of our build, run the flaky tests either at the end or as part of a build so we at least know if they're getting better and we could run reports. Right now, that's all pretty much a manual process. Another thing is getting the failure stack trace. Like with the BEP, we can get to the file, but the way our continuous integration works. We can't get to those files unless we save them off while the build is running. But that's pretty much just for our environment. And then the next thing that we want to work on is getting the caching and remote execution. The remote caching we need because, one, it'll be faster for developers. It'll also help with our continuous integration, and that our continuous integration could use the cache. Some of the issues we're running into now is that the Java targets don't share cache entries between build platforms. So we have our builds run on Linux platform, but most developers are running Mac. So they really can't share. So we've been looking at the Bazel build form project for remote execution because one of the problems with our caching is it's implemented within Jai and Ix, but the problem with it is we have security saying they don't want anything in the cache that comes from a developer machine or not from outside of our build servers. So that's a constraint that we have. So we're hoping that with a remote execution, that can be run on the build servers. We can run those, and then the continuous integration can then use those caches to help build, to relieve some of that pressure, so everything doesn't have to be built all the time. Some of our issues so far is running with the build form is the build fails. There's really no indication. It just says, hey, exit 34, try again. The logs don't really point you to where the problem could potentially be, even though everything seems to be running locally. So we're hoping that gets fixed soon. The next, Simon's going to be up to talk about our Maven integration.
Hi. So as Peter mentioned, we are doing this this very gradual transition to Bazel. So we still have a lot of builds out there that use Maven. And so when we are considering code to move into the Bazel monorepo, we copy all the Java over and we delete the Maven files and we delete the Maven automation. And that's great if this is a service. It just gets built and then deployed using Docker and we're done. But if the thing we're moving is a library, we have a problem because most likely existing Maven builds still reference that library through the POM as an artifact. And so what we need to do in the monorepo is to be able to publish libraries as Maven artifacts so that the Maven builds outside can still consume them. And so we went through a few iterations on this. We're still kind of playing around with it. Initially, we had custom rules in the build files to generate POMs, to generate Java source jars, Java.doc jars, install into the local Maven repository for testing, and then also for uploading to our public repository. We didn't like that so much. It kind of made the build files more complicated than we'd like. And we also realized that the Maven command line actually provides a lot of this functionality, given that we have a valid POM file. So the current solution we have is for a library in the monorepo that's built using Bazel that needs to be shared with Maven builds. We have a single build file, a single Java library target in that build file, and an additional file that we made up that marks this library as being exportable. That file tracks the Maven-specific metadata. So we want to make sure that the monorepo is the single source of truth for all metadata. So this file truly only has data that is specific to Maven, and we only have group ID and artifact ID right now in there. We use Bazel query to look at the dependencies the Java library target in the build file references. And if the dependency is a Maven jar from the workspace file, then we just put it in a generated POM. It feels right at home there. If it's a source level dependency, another Bazel package, then we look at that package's build.pom to find the group ID and artifact ID. So that means obviously that any source level dependency the Java library has needs to also be exportable as a Maven artifact. We then have a script, an external Python script that takes the output of Bazel query with the dependencies. It takes the content of the build POM file, and it generates a very simple but functional POM XML. That's for jar artifacts in Maven. We also support POM artifacts. We typically have these as parent POMs. They provide dependency management, and those are generated using a template file. So there's no build file here, but in the monorepo we still keep this information so that it's all in one place. And the template file, the only non-static content in there is typically library version information, and we get that out of the workspace file with a special syntax. So again, to have a single source of truth, we don't duplicate that. And with this, and then for the rest, so now we have a valid POM. For everything else, we delegate to the Maven command line. There's a simple shell wrapper. So to generate javadoc jars, source jars, install into local repository, and upload to the public repository. That works okay. Another very important part is actually testing that all these generated artifacts are consumable by Maven builds. So we have continuous integration for that. We picked a subset of all of our services, the most important ones, and we build those in our CI system, and they continuously use the latest artifacts produced by the monorepo. And that way we make sure that they're consumable. So with this setup, we have currently around 60 Maven artifacts in the monorepo, and we've pushed a few successful releases to the Maven repository. And by successful, I mean that the consumers of the artifacts have noticed any difference. So the move to the monorepo has changed the POM structure, but not too much. So the artifacts were still consumable. Next steps in our migration. First, I should say that the migration to Bazel has been quite smooth. We thought we would run into a lot more issues, but everything has been going pretty well. The big thing for us now is IDE support. The IntelliJ Bazel plugin works, but it's not as smooth as IntelliJ is for a Maven-based project, and we would really like Eclipse support because Salesforce is a big Eclipse shop. So if any of you are working on Eclipse support or are interested in Eclipse support, please come and talk to us. We want to open the monorepo up to more teams. Right now it's only us, and IDE support will be a big issue then, because people, they want the same experience that they're used to. Like Blaine said, we're going to turn on remote caching and remote execution. So if you are also using, is it called Build Farm? Yeah, the Build Farm project, please come and talk to us, because we are trying to get that to work. And we are trying to move in more non-Java languages into the monorepo. That's all we had. So we have time for questions or early lunch.